All right. Hello, welcome back. We're doing the second part of episode 2, Hello Triangle. So we're going to be finishing up rendering our triangle to our window. So let's jump right back into it. We left off with loading in our different shader files, our triangle, vertex shader, and fragment shader. And now we are kind of ready to get into actually doing GL functions. Whoops. So let's go ahead and get started here. And we're going to start off by defining a few things. We're going to be defining our VS shader. That's going to be locating or linking our OpenGL and our graphics card to our program. So we're going to use VS, FS, and program as the three main things that we'll be accessing with. And the next thing is we're going to be using some debug tools. Particularly, we're going to be using a GL int called success, which if it returns anything but 0, we'll say that it is successful. And then we will also need to keep all of our errors in and anything that went wrong into an info log, and that's going to be 512 characters. Now, something that I just scrolled over and found out is we didn't actually load GLAD. So we downloaded GLAD, we inputted it into our project here, but we didn't actually init it. So this is a kind of a good opportunity to showcase what happens when you don't init GLAD and you just run OpenGL on GLFW. So let's go ahead and do this statement here. Our first GL function, GL create shader, and we will do GL vertex shader as its input. Whoops, got to get the semicolon outside of it. And if we run this right here, we're going to get an exception thrown. So this is a runtime error. It's going to say access violation, executing location, whatever. And that pretty much means that it wasn't able to link up properly with our graphics card to call this create shader function. And that is the magic of GLAD that fixes that issue here. So right after window, let's go ahead and make use of our include of GLAD. So to do that, we will do, let me find the function here. Let's do an if statement, just like glfw init, GLAD load GL loader. And that takes an input of GLAD load proc, but we're going to have to cast what glfw has to offer under C style as a GLAD load proc. And the glfw proc address is gotten using glfw get proc address. And what this basically is doing, at least from what I think I looked this up a while back, but it is just linking together our graphics card, like the entry point for OpenGL. And like every machine is different, so GLAD kind of smooths over that transition, I believe. So if GLAD doesn't load properly, we need to properly also error. So let's just say failed to initialize GLAD. And return 1 if that doesn't end up happening. Now, if we compile our program, you'll notice we'll get our window back. So now that GLAD's loaded properly, we no longer have that exception, and our program runs just perfectly. So let's go ahead and finish compiling our vertex and fragment shaders. Let me scroll down in my cheat sheet over here and get our next GL function going. So GL shader source, and we'll need to input our shader, the amount of shaders we're creating, the string. So the string would be the file name, I believe, or sorry, the C string. So that would be, oh, we haven't defined it. So let's go ahead and define those. So right now we have VS code and FS code inside of a string function, but we need to actually convert that to C string. So to do that, we'll go ahead and convert it using auto. So we'll call this FVS code C str, and that is equal to VS code dot str, or sorry, CSTR. And do the same thing for FS. And then that should input, or that should be the shader source input for us here. So we just need to do the ampersand to create a reference to our C string. So VS code CSTR, and then we need to input the length, and we don't care about the length. It can be as long as possible. So we'll just go ahead and input null pointer for that. All right, now the next step is, and our next GL function is compiling. So go ahead, GL compile shader, and then we'll input VS. Now, if we wanted to, we could actually just stop here. If we just trust the fact that our compilations are just going to be 100% successful and nothing is going wrong, then we can just stop here. But I mean, it's programming. It's very likely things to go wrong, so we have to make sure we catch any errors. So to do that, we will need to be calling the function here, GL get shader IV, I believe. Get shader IV, and we need to input the shader here. So that's VS, and then the P name. So P name, we're going to be getting the compile status. And then parameters, we just need to input our success flag. So if our success is not 0, then that means our compilation went through all right. But if it is 0, we have to make sure we log what went wrong. So to do that, we have to call the GL function get shader info log, and then input the shader, the buffer size, which is 512 if you look over here. Our length, we don't care how long, and info log, and is just inputting our info log array here. Now let's just print these out. So standard C error, and we'll say vertex, God, I can't spell today, shader compilation failure. And then we'll just say VS and input the file path here. So VS file path. Let me actually zoom in a bit, just so you can see the text a bit better. Next, we will see error. Or let's just continue on with more right-angled brackets, and also input the info log to see what exactly went wrong. And then end line and return 1. All right, so that should successfully compile our vertex shader. We can actually just go ahead and run that. See if everything's all right. So our vertex shader is compiled correctly, so we can just exit out of that. let's go ahead and compile our fragment shader. Now to do that, it's just the same thing as our vertex shader, except we're replacing vertex with fragment. So this is fragment, this is fs, this is fs, this is fs, fs, and it's a lot of tedious work, but it'll be fine. This is just kind of programming in a nutshell. Info log. I think this is everything. It looks like it is. So let's go ahead and run this. See if our fragment shader is working. And we got our window. So our fragment and vertex shader were compiled correctly, which means we did everything perfectly. So give ourselves a pat on the back for that one, for not messing anything up. So the next thing we're going to be doing is compiling our program. So what a program is a combination of vertex, fragment, and geometry shaders all packaged into one single reference point on the graphics card. So to do that is a similar sort of process to what we've been doing with FS and VS, but a little bit different because we're going to be calling GL create program instead of create shader. So GL create program is going to be what we're going to be calling now. And then we're going to be attaching shaders to our program. So let's go ahead and attach shader. And we're going to input our program and then our shader, so VS. And then the same thing for FS. And lastly, we're going to link it together. So we're going to link everything all packaged together. So we're done attaching. So we want to link everything together. And if everything linked correctly, then we should check for that, because you can have some problems where GL position doesn't really line up with the next step, or color coming from like the geometry shader doesn't line up with the next step. It's just all just dumb errors that can occur, but are not compilation errors. They're in fact linker errors. And to do that, we're going to have to do the GL function, GL get program IV. You guessed it, pretty similar to what we were doing with shaders. And then let's input a bunch of stuff. Program GL link status to get the link status, and then the parameters we're just going to be using or reusing our success flag, or a reference to our success flag. Then if not success, just like with our shaders, we got to print out some info about what went wrong. So get program info log, and this time we're going to input program 512 null pointer, and then our info log. And let's just standard C error, program linking failure. And we'll just end it off with our info log. We don't need to, since it is involving all of our different shaders, we don't really need to specify which ones are occurring. I guess if you have like multiple different shader files, then we'll need to fix that in the future. But we're actually going to be changing a lot of the logging and how this is actually taken care of in the future. But so for now, since we're only using two different shaders, inputting like what shaders were involved in the linking doesn't really matter. All right, so let's go ahead and run that. See if we have any linking errors. And it looks like we're clean. So linking went all right. So now we can actually just get to rendering. Well, I guess first we should probably delete the stuff we're not using anymore. So we can actually delete GL delete shader. We can delete our VS and FS shaders now. Since we have them linked up and they're all together now packaged in their own program. And let's call a GL use program so that our graphics card knows what program it's going to be using for our rendering. So this is important to be called. And we'll be using a lot of this, especially once we actually go to rendering or creating our own renderer. And now we have to, this is kind of like the complicated part. After we've done all of the compilation of our shaders and such, we got to build our float, our data set. If you remember from the pipeline, that's like the beginning data set that we'll be needing. And we're going to name this vertices. And let's just hard code it for now, but in the future, obviously, we're going to want to make things line up pretty easily. So if you remember correctly, our screen is going to be an it's by like -1 to 1 with the center point being 0. So if we want to draw counter or clockwise, we got to start in -1, -1, which is the bottom left corner. And then we are going to go straight to the right. Oh, I guess it's counterclockwise. I've been saying clockwise the entire time. It's counterclockwise. That's how you render. It's counterclockwise. These are all. Make sure we have F involved in these as well. So we're going to go to the right corner because it's counterclockwise, not clockwise. I've been spreading misinformation. And then finally, we're going to have the top here at 0, 1. So that's all well and good. Let's go ahead and then go on to our next step, which is setting up VAOs and VBOs. So what those are, or what the VBO is, a vertex buffer object. So that's going to be like the actual points stored in our vertices. So what we're going to be doing with our VBOs will become apparent pretty shortly. And the VAOs, that's our vertex array buffer. So that's going to be like signifying how we're packaging our triangles together, how like where exactly like the points are signifying, since like this is currently located in a float array. We have to package these points into, well, points. They got to be in different vectors. So the VAO controls that, while the VBO kind of controls, like signifies a space in the graphics card which you can access and render towards. I don't know if that made any sense, but it doesn't really matter. You can just copy code and then kind of learn as you go. So let's go ahead and generate our vertex array, or vertex arrays, I guess, but we're only generating one here. It's going to input our VAO, and then we're going to gen our buffers. So where we're storing our data, it's going to be 1, and it's going to be our VBO. So did I spell? Oh, it's buffers. And then let's go ahead and make sure we signify that we're using our VAO. So we have to call the GL bind vertex array, and then signify that we're using VAO here. And then finally, or not finally, we still got a ways to go. We got to bind our buffer data. So to do that, or we got to bind our vertices to our buffer data. So to do that, we first have to bind our buffer. So GL bind buffer. And the summary inputs, we have to say what kind of target it is. It's going to be an array buffer. I've only used array buffers before. I don't know about the other sort of targets that you can use, but I assume they have differences. I've only thought of this in kind of like just storing in arrays. I'm assuming that's just kind of the standard practice for it. Then we have to buffer data, and to do that, or pretty much just load in our vertices into our buffer that we cleared out in our graphics card. So to do that, we again pass through GL array buffer as our target. Our size is whatever the size of vertices is. And don't get that confused with like arrays.size. It's not like 6. We don't have 6 that we're doing. Then the actual data, so vertices, we got to actually get like the memory size of it. And then how we're going to be drawing it is we're going to be drawing it statically. I looked up exactly what the other, there's like dynamic draw, and then there's one other. I haven't been able to use effectively the other ways to draw or like ways to buffer data. But static draw just seems to work well for what we're going to be doing. So we're going to be continuing to using GL static draw. Then lastly, we have to set up our vertex array. So how we're going to be cycling through our data, we're going to have to set that up. So we'll do GL vertex a trib pointer. So we start off at index 0. So that's this value here, and we want to convert this float array into pretty much pairs of 2 different float values. So to do that, we set up in the trib pointer. It goes from 0 to 2, or that's the size is 2. So we want 2 different float values, and we're going to be passing through the type as GL float, and then normalized. We don't want it normalized, so we're going to pass through GL false, and then our stride. So what we're doing is like every single 2, you want to signify that as like our data point. And this is going to also line up directly with what we did in our triangle VS. So if you notice, we have our location and position here. So we're just inputting every single stride. We're inputting position at location 0, which is signified by I think it's this. I think this is the location. I'm trying to look. I believe that's correct though. So the next thing that we'll need to do is this is signifying the size. So to do that, we do size of, and we'll just do size of float. We could do GL float, but they are the same size. And then the pointer. So where does it start off at? We start off at 0. So let's just cast our GL void here, and then cast that at 0. So null pointer is also an acceptable answer for that. And then we have to enable our vertex attrib pointer, attrib array. This is actually, sorry, this is not signifying what the location is, location 0. This is how you like link those 2 together. So we'll enable vertex attrib array and signify 0. So this is going to set up so each of our points passes through this position value and then calls this shader function. All right, so we have the initialization all set up. So we can actually just start rendering. We're kind of close to, well, we're like 5 minutes past what I would like to be for a video length. However, I thought I might as well just finish this one off. And so we're just doing that. So the first thing that we're going to be doing for our rendering, at least in our while loop, is we're going to be clearing the color to black every single frame. That is just so that, you know, if we do delete something off the, like off from being rendered, we want to make sure we're constantly clearing the screen so it doesn't show up at later points. So this is black 0, 0, 0. And then we'll call GL clear, and then GL color buffer bit. I don't remember what exactly this does, but it is important. You're going to need it, and you're going to need to call it every single frame. So this is the final thing that we'll need to be doing, and that is GL draw arrays. And that is going to pretty much draw all of this hard work that we put in over here with the VBOs and VAOs. And to do that, we're going to do GL triangles. And then we're going to be drawing 3 points starting at 0. And let's go ahead and run this, and voila, we got ourselves a triangle on the screen. Look at that. First try. But that should do it for today. Thank you guys so much for watching. I can't stress how much it means to me for you guys to enjoy these videos. In the next episode, I don't know what we might be doing sprites. I think we're going to be rendering some images to our triangle, and well, actually, I think how I wrote it, we're going to be rendering to a square. So we're going to have a nice little like sprite guy on the center of our screen. Anyways, thank you so much for watching, and I'll see you in the next episode.